Okay, now let us look in detail into the process of digestion. We'll start with the mouth because it is the first part of the gut, first part of the alimentary canal. The mouth is where food is being inserted into the alimentary canal by the process of ingestion. So we'll be looking at digestion at most of these structures like the mouth, the stomach, the esophagus itself, and the intestines under two major topics, under mechanical digestion and chemical digestion, like we explained earlier. So mechanical digestion in the mouth, what happens? It involves the mechanical breakdown of food into finer particles by the teeth through mastication, which is chewing. And you'll realize that the teeth can't break down food if there's no muscles involved. So the muscles around the mouth or the jaws also assist in this mechanical breakdown. So we have two things here, the muscles and the teeth, which physically break down food by chewing. And the food is broken down to a pulp to make it soft. For what reason? This is to make the particles small enough so that we can increase surface area for enzymatic action. We've explained that already before. And secondly, to mix the food thoroughly with slimy saliva. Inside saliva, saliva is made to be slimy because it contains mucus, that we'll see. It contains mucus so that it can be easily swallowed and also pass through the esophagus very easily. Imagine if you had to swallow food which is completely dry. Your esophagus, your throat will even hurt. So the saliva is slimy, it is watery, so that the food can be slippery and moist for easy swallowing. And while that's happening, the tongue also plays a role in this mechanical breakdown, because it is the tongue that moves the food around the mouth always, and without you noticing, your tongue is always pushing the food towards the teeth, putting the food in between the teeth so that the teeth only go up and down or in semicircular motions so that they can crush the food. And the tongue also will then help with saliva to roll the food to form what we call a bolus, which is a mass of food, a round mass of food, like a little ball. That's why we call it a bolus. And it is this bolus, again, which will be pushed by the tongue to the back of the mouth or the throat into the pharynx, where it can then be swallowed. Now, the chemical digestion in the mouth. When food is found in the mouth, there is some kind of reflex action instantaneously without you noticing or without you controlling it. That doesn't occur according to your will. It's involuntary. When food is present in the mouth, salivary glands will start producing saliva such that they are released into the mouth. Now, what does the saliva contain and why is the saliva important? The saliva contains water. Most of saliva is water, so that the food can be softened, can be made wet and not dry. This is to facilitate chewing. Again, remember I said saliva contains mucus. That makes the food to be slimy so that it can lubricate the food, again to facilitate chewing and even swallowing. Saliva is alkalinic. It's not acidic. Hence, it will provide some sort of neutral environment or otherwise slightly alkaline environment, which is necessary for the action of the enzyme found in the mouth. The enzyme salivary amylase, which is present in saliva, would want to function in an alkaline or neutral environment and not acidic environment. Remember in your grade 10, you were taught that enzymes are affected by temperature and pH. So some enzymes work best in alkaline environments or in neutral environment or in acidic environments. The salivary amylase that's produced in saliva found in our mouth will want to work in an alkalinic environment. That is why it is important for the mouth to be alkalinic so that the salivary amylase can work efficiently. Otherwise, if it is acidic, if the environment is acidic, then salivary amylase cannot work. Then the chemical breakdown of starch into glucose will not occur. So this enzyme salivary amylase would only work best at an alkalinic environment to break down starch to form glucose, which is small enough to pass through the cell membrane already, because that's the simplest unit of sugar. Now, the process of swallowing. After all the digestion has been, after the food has been broken down and it's already in fine pulp and well broken down enough, by reflex, we also swallow. Or by reflex, we get to understand that the food is good enough for swallowing. And how does the swallowing action occur? It's assisted by the tongue. The tongue will move and press upwards on the palate, that's the roof of the mouth. Will press upwards against the palate and backwards, so that food is pushed to the back of the throat. At the same time, the epiglottis, which is a small lid-like structure, we saw that when we were looking at the external structure of the alimentary canal, the epiglottis will close the glottis. The glottis is a small aperture, a small opening that leads to the airway. We saw that again when we were looking at the structure of the alimentary canal. That leads to the trachea. So that's the reason why we are able to breathe with our mouths, because the air passes from the mouth into the glottis and into the trachea. But then there is a catch also. That opening can also serve as a passage of food into the trachea, but we will not want this because it will lead to choking. That's why when you are eating, if you are eating while and swallowing while talking, the epiglottis might not close the glottis and food particles will fall into the trachea and you will choke. The choking is a reflex action to assist you in coughing out that food particle, otherwise it's going to cause infection to the lungs. So during swallowing, the normal action is such that the epiglottis will close the glottis when swallowing. This is to prevent choking, so that the food will go straight into the esophagus and not into the air pipe or the trachea. When all this is done, the bolus of food is pushed into the pharynx and forced down into the esophagus. Now, down the esophagus, what happens? The food will move down the esophagus by peristalsis. And peristalsis is the rhythmical contraction of the muscles of the alimentary canal, causing food to move along the gut. So peristalsis doesn't occur only in the esophagus, it also occurs in the stomach, it occurs also in the intestines, the small and large intestine. That's how food is moved out or down the gut, by reflex action. When food gets into the esophagus, you don't have control over it again. Everything here occurs involuntarily. That's why the muscles that surround the alimentary tract from the esophagus downwards are made up of smooth muscles, which function as involuntary muscles. Now, when food is moving down the esophagus, it moves in the form of a ball. That's what we call the bolus. The esophagus is made up of two types of muscles. We have circular muscles. You'll see them here like lines, circular muscles. And we also have longitudinal muscles. They are kind of straight downwards. So we have circular muscles and we have longitudinal muscles. As the food is moving down, for it to go downwards, the circular muscles which are found at the back here, at the back of the bolus, will contract. That's why you see the arrows are moving inwards. The circular muscles at the back will contract. Meanwhile, the circular muscles at the front of the bolus will relax, such that at the front the esophagus widens, at the back the esophagus contracts. Okay, if you see, for example, these ladies who make maguenya, when they put the dough in their hand, they want the dough to flow in one direction to fall in the fry pan. So what do? They will squeeze the fingers behind at the back. They squeeze those fingers and they open up in front so that the dough flows in one direction and they cut it out. That's what happens. We squeeze behind, we open in front, and it flows. So in the esophagus, in the stomach, and in the small intestine, that's how food is moved in a wave-like manner. I squeeze, I open, I squeeze, I open, squeeze, open, squeeze, open. We see it is going in one direction. That's what's happening here. Circular muscles at every instance at the back of the bolus will contract inwards, and longitudinal muscles at the front here will also contract. Meanwhile, the circular muscles at the front will relax. It means the longitudinal muscles at the back will relax while the circular ones are contracting. In front, the circular ones are relaxing, longitudinal are contracting. The circular muscles and longitudinal muscles always function in opposition. They function antagonistically. It means when the circular muscles are contracting, the longitudinal muscles are always relaxing, and vice versa. The opposite occurs, and the food is going to move in a wave-like manner. That wave-like manner of muscles contracting and relaxing, or in a rhythmical manner, is what we call peristalsis. That's the way the food is moved down the esophagus and the other parts of the alimentary canal as well.